Chemstars, welcome to today's Came Fun with Goodness. Today we'll be talking about calculation of mole comprehensively. In the first definition, we define mole as the amount of a substance that weighs the same as the gram atomic or molecular mass of such compound or element. Then in the second definition, we define the mole of a substance as the amount of a substance which will contain 6.023 exponent 23 particles of such substance. And in the third definitions, we define a mole as the amount of a gaseous substance that will occupy a volume of 22.4 dm³ at STP. Owing to these three definitions, comprehensively, a mole can be defined as that amount of a substance which contains 6.023 exponent 23 particles of such content and would weigh an exact weight as its gram atomic or molecular mass and occupies a volume of 22.4 dm³ at STP. Whichever way you are asked to calculate the number of moles, be it a compound or an element, it must obey or line up with these three principles or criteria: the molecular volume, which is 22.4 dm³, the gram atomic mass or molecular mass of such compound, and then the number of particles of such element, which is 6.023 exponent 23. Having said this, let's go over to the board and solve the question on the board together. We are going to take it step by step, bit by bit, so that we'll be able to understand this question. Now, the question is, calculate the moles and number of electrons required to convert 3.55 grams of chloride ions. That is to say, the chloride is in its ionic stage, which is Cl-. So we have something like this solution. This is chloride ion. So they said, what is the number of moles? That is the first question. And secondly, the number of electrons required to convert. They gave us the mass of the chloride ion, which is what? 3.55 grams. And you know that mole is equal to mass over molar mass. We'll get the mole. And that basically answered this question for us. Are you getting me? Now, this chloride ion is converted to what? Atomic chlorine. So, this is the ion. When it loses electron, it will fall back into its neutral state, which is atomic chlorine. They did not say gaseous chlorine, atomic, just one. Are you getting me? If it is gaseous chlorine or chlorine gas, it would have been two here, but just atomic, only one. Please do not forget. This is the equation for this reaction. 3.55 grams. When you divide mass over the molar mass of chlorine, you will get the mole. Are you with me? Now we will say that mole is equals mass over molar mass. This is equals to what? 3.55 over what is the molar mass of chlorine? 35.5. And when you divide, have 0.1 mole. So this answers the first question. Calculate the number of moles. Now the second one, the number of electrons. Now this one obeys what? Number of particles. 6.023 exponent 23. How do we go about it? 1 mole of chlorine ion contains 6.02 exponent 23 electrons. Okay? Now, what is the number of mole that we are able to calculate? 0.1 mole. Now, we say 0.1 mole of chlorine atom contains X electrons. We do not know. Are you getting me? Good. When we have established this relationship, the next thing we do is to cross and multiply, okay? So 0.1 times this and X times this. And of course, X times 1 is equals to X. So I will go ahead and say X is equals 0.1 times 6.02 exponent 23. This is equals what? By the time you press your calculator, you'll be getting 0.602 exponent 23. You can further write this as x equals 6.02 exponent 22 electrons of chloride ion. So that basically solves the A part of it. This one is the number of moles and this one is the number of electrons. Now quickly, let's go back to B part of it. If all the chloride ions in A, now the chloride ions, if all the ions in A had been converted to chlorine gas, this is where you now talk about your Cl2. Are you getting me? Had it been all, this is chloride ion, not all of them were converted to chlorine gas, but now all of them had been converted. It means that when we write this equation, this one has to be a chloride gas and no longer atomic chlorine. So we have something like this: Cl minus electron to give us chlorine gas. Now look at this equation. What did you see? It's no longer what? Balanced. This is 2 chlorine, but there is 1 here. What do? We add our 2 to this side, and then we balance the ionic charge by adding 2 to the number of electrons. So all the chloride ion has been converted to chlorine gas. That solves that question. Now the question is, calculate the moles of chlorine gas produced. The moles here, just as we have done here, we also have to do the moles for this side. It's as simple as that, okay? So what do? It is still the same mass, 3.55 grams. Are you getting me? So what we are going to do here is this: mole is equals mass over molar mass. This is equals 3.55 over what is the molar mass of chlorine gas and no longer chlorine atom. Are you with me? Good. This is what? 71. Why is it 71? 35.5 times 2 give you what? 71. Are you with me? Good. Now when you divide through, you will be having 0.05 moles. Now the second one says the number of chlorine molecules produced. The number of chlorine molecules produced. We establish the stoichiometry relationship. Are you getting me? And use it and solve it just as we did here, okay? Now we say 1 mole of chlorine gas contains 6.02 exponent 23 particles. Now what is the number of moles gotten for chlorine gas? 0.05. So 0.05 moles of chlorine gas contain S particles. That is the stoichiometry relationship. So X is equals, X times 1 is 1, okay? So X is equals 0.05 times 6.02 exponent 23. Therefore, our X is equals 3.01 exponent 22 particles or molecules of chlorine gas. Beautiful. So that is the answer. We have solved the one of the number of molecules produced. Now the next one has to do with the volume, which is 22.4 dm. We're talking about the molecular volume. You still solve it by establishing the stoichiometry relationship, okay? So we say 1 mole of chlorine gas is equals 22.4 dm cubed at STP, okay? Now, what is the number of moles? 0.05 mole. 0.05 mole of chlorine gas will occupy a volume of what and STP. You simply do your cross and multiplication. X is equals 0.05 times 22.4 dm cubed. So X is equals 1.12 dm cubed at STP. So this is the number of volume. Are you with me? So we have solved this question. Now navigating away from simple to complex, from known to the unknown. Are you with me? Obeying these three criteria or definitions of mole: the mass of the substance that weighs the same as the atomic mass. The second one talks about the Avogadro's number, that is elementary particles, and the other one talks about the gram molecular volume. So from there we'll be able to navigate our way and solve this. Please, at the end of each tutorial we have our follow-up questions. Do well to solve them, post and share so that we all learn together, okay? If you're yet to subscribe to this channel, please go ahead and do that, okay? Be part of this family. This is Fun, where we make chemistry fun. I'm Ijeoma. I'll see you right there in my next video. Bye.